Right, class, on this podcast we're going to look at ionic compounds, as part 2 of ionic compounds, where we're dealing with a metal that has a charge that could be one charge or another charge. So I call these the either-or metals, and they're always the metals in the middle of the periodic table, with the exception of a bing, 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 1, 2, 3, silver, zinc, or aluminum. So if it's not those, it is a multivalent, which just means more than one charge metal. Okay? So ionic compounds, we're just going to call with either-or metals. And by either-or, I simply mean it's either this charge or it is that charge. Either-or metals. Alright, so if you watched the previous podcast, we started with, I gave you a formula and we wrote the name. So I'm just going to put a couple formulas here. Let's see, let's come up with one more, or that should be good to begin with. We'll do this one as well. Alright, so you're given 4 formulas, okay, and we want to come up with the names of these formulas. So, when you write these, we're going to put immediately, oh, that's copper, so we're going to go ahead and write copper. But if we look on the periodic table, we're going to go, oh, copper. It's there in the middle, so I don't know the charge of copper. So I'm going to immediately put some parentheses after copper. And then kind of just going back to what we did last time, if it is a binary compound, okay, so if there's just 2 elements present, they always end in the same ending, all right, and they always end in "ide." All right, so as we look at our nonmetal, we have iodine, but it's going to end in "ide," so it's going to change to iodide. So we have copper, blank, iodide. Notice on my last example, I also have copper, blank, iodide. Alright, and we're going to fill in the parentheses in just a second. Alright, so we know that ionic compounds have to have a neutral charge overall, or our negative charges have to add up or cancel out with our positive charges. So if that's the case, what we're going to do is we don't know the charge on copper, but we always know the charge on iodine. So if you look on the periodic table, we see it's a halogen, and its charge is -1. Okay? So the way this formula is written, we have 1 copper for every 1 iodide. So because really our subscripts are 1 to 1, even though they're not written there, but because we have 1 of each, if we have 1 iodine with a -1 charge, and we have 1 copper, that copper must be a +1 charge, because +1 - 1 = 0. So if that's the case, this is going to be written as copper 1 iodide, alright? Because the Roman numeral tells us the charge on the metal, alright? And notice the charge on my copper is a +1. As we skip down to this one, again, iodine is always a -1, okay? We don't know what the copper is, but we can always figure it out based on what our anion's charge is, or our nonmetal's charge is. So this time, I don't have 1 iodine, I actually have 2 iodides. So I'm just going to multiply -1 times 2 equals -2. Alright? So I have a total -2 charge on my compound. So if my total negative is -2, then my copper has to be a +2. And because I only have 1 copper, the charge on that 1 copper must be a +2. So this is really copper 2 iodide. I think you'll remember in the packet we did, the POGO packet, it talked about usually the Roman numeral doesn't match the subscript on the metal, it typically matches the subscript on the nonmetal. Okay? So with that in mind, let's hop up to this one. So if we look at this one, Fe, okay, that is iron. If I find iron on the periodic table, it's a metal in the middle. Okay? So I'm going to write iron, and immediately after that I'm going to put parentheses, because I know it's going to have a Roman numeral. And then I'm going to put ox something. And oxygen has to end in "ide" because it's binary, so I'm going to put oxide. Alright, so in this case, oxygen always has a -2 charge because it is a chalcogen, so it always has that charge. Okay, so I'm going to erase these charges on my copper just to have a little more room. And because oxygen is a -2 and I have 3 of them, it really adds up to a total of a -6 charge. Okay? So my positive must be contributing a total of a +6 charge, because my positives and negatives need to add up to 0. So if I have 2 irons, and they have to add up to -6. The charge on each of them must be a +3. If it's a +3, whenever I write my name, I'm going to write iron, Roman numeral 3, oxide. Okay? Because the charge on my iron is a +3. And again, notice, the charge on your metal typically is the subscript on your nonmetal. Alright? Our last example is MgO. Alright? And again, Mg is magnesium. Alright, if we look on the periodic table, if we look at magnesium, oh, look at that, it's in the second column, it's an alkali metal. So because it's a metal I know the charge of, I don't have to put parentheses. So I'm simply going to write magnesium oxide, and I am done. Why do I not need to put parentheses here? Well, if I put parentheses, what is its charge always? It's always a 2. So it's simply redundant to put a 2 if magnesium is always a 2. And that is why we don't need the Roman numeral. Alright? So again, we have 3 examples of either-or metals, and magnesium is not an either-or metal. It is always a +2. Alright, so that is formulas to names. Next, we're going to go names to formulas. So I might have nickel, let's call it 2 oxide. And let's do, what's another one? We can do iron 3 sulfide. And lastly, we'll do something a little bit different. We'll do chromium 2, we'll call it phosphide. Alright, in my opinion, these are a whole lot easier than going from formula to name. It's much easier to go from name to formula. So in these examples, we're simply going to write the symbol for nickel. So nickel is Ni. And we're going to write the symbol for oxygen. And then we need to write our charges. We're going to balance our charges just like we do if we have metals with always the same charge. Alright, so that stays the same. And oxygen, we know, is always a -2. And nickel, in this case, because it has a +2 Roman numeral, it has a +2 charge. So +2 minus 2 equals what? It equals 0. So simply, our formula is NiO. Our next one is iron 2 sulfide. So again, we're going to write our metal. The symbol for iron is Fe. And sulfide comes from sulfur. Sulfur is a chalcogen, just like oxygen, so it's a -2. And iron in this case is a +3. So we have charges that aren't balanced already. So we need to come up with the least common multiple, and the least common multiple of 3 and 2 is 6. So 3 times what is 6? A 2. And 2 times what is 6? A 3. So this really becomes Fe2S3. Alright, and our last example is going to be chromium 2 phosphide. And this one is going to look like this. Chromium. And then we have phosphide. And phosphide is right there underneath nitrogen. We kind of talked about this. It's always going to be a -3. Chromium happens to be a +2 in this case. So again, our least common multiple is going to be 6. So 2 times what is 6? 3. 3 times what is 6? 2. So this formula is Cr3P2. Alright, and that is really how it goes with either-or metals, those metals in the middle of the periodic table, with the exception of silver, zinc, and aluminum.